Okay, now we can do this. So we're paying attention to the left-hand side, all right? And so you should have said, okay, because it's kind of stretched out, right? Those are long wavelengths. They are occurring not very frequently, so low frequency, which in turn means low energy. Frequency and energy are directly related. Wavelength is going to be inversely related to those, okay? All right, so that's what we were looking at for that, okay? So usually what we write off to the side is FEW, so few, okay? So when you're looking at this is showing that whole idea of low frequency, low energy, long wavelength. Low, low, long. Okay? Number 7, it said you're doing the same thing, but now we're going to pay attention to the scrunchioed side, so the one that's a little pushed together. So that is showing evidence of short wavelengths, high frequency, and high energy. Okay? So again, we can write FEW, and we're thinking high, high, short. But big idea here is making sure that you understand frequency and energy are directly related and they are opposite of whatever wavelength is going to be. Okay? Now, we're going to take a pause break before we go on to number 10 to write out our nice little electromagnetic spectrum right here. Even though you guys have that little half sheet, this will be a quick place for you to look for a couple facts that I'm going to go over right now. All right? So I would make sure that you copy this part down. So we're going to start with radio. Then we're going to say microwave. Then I'm going to say infrared. Then visible. Then ultraviolet. Or UV, right? And then X-ray. And finally, gamma. Okay? All right, so back when I was in college, like years and years ago, a long time ago, but when we had to for sure have it memorized, I've never forgotten it, but the saying that he told us to remember was rabbits mate in very unusual exotic gardens. All right, so I'm going to put the poster up, and that way it'll be there just in case. It's a random sentence, but I will say I've never forgotten it. All right, so rabbits mate in very unusual exotic gardens. You do not have to write that down if you don't want to. All right, so that's just showing us the order. Now, you ask, okay, why do we even care about the order? All right? And the reason we care about the order is because they match up to this idea of frequency and energy being low and wavelength being long versus high, high, short, right? And so this order that we just wrote out matches identical to this image. Meaning, if on your test or on the quiz, I have this reversed, is it starting with radio still? No. All right? So, it's important that you know that this picture matches to these words in this exact order. Okay? That's the whole point of that. Now, most likely we'll probably be giving you somewhat of that spectrum with the words, so I don't think you have to have that memorized with that little funny, weird sentence. But what you will be responsible for is knowing which ones are high and low, right? So the easy way to kind of keep track of that, which end of this spectrum created the Hulk? Gamma, right? So we're gonna put we're just gonna put Hulk right here. Okay? So if you are not familiar with the Hulk, he's the large green guy who is he's a superhero, but when he evolves like that, he seems very angry. All right, so he's very destructive, does a lot of damage, takes care of things, right? So He, would you say, has high energy or low energy? High energy, crazy, right? So go ahead and put Hulk and high energy. If you can remember that is correlated with the gamma side, then you will know how this whole thing goes, because we know that energy is directly related to frequency. So high energy, high frequency, tiny itty bitty wavelengths, right? They had to penetrate through his skin, so they had to be these little short wavelengths at a very high frequency. Okay? So gamma is our Hulk side, all right? High energy. You can really relate every single thing to energy, and it kind of fills in the blanks for everything else. All right, the opposite end is radio, so we're going to go ahead and say all around us. Okay, radio waves are all around us, and from the looks of it, just looking at you guys, I don't see anyone having adverse reactions to the radio waves. So, low energy, yeah? Oh, you guys all thought that I was actually. So, whole idea is that the low energy waves that are all around you right now, they're hitting your skin, they're hitting your head, all of that. None of you guys feel like you're getting hit in the head right now, right? Okay, so very low energy, a little bit more on the safer side. The higher energy stuff does a lot more damage, okay? Forgot what I was going to say. Oh, I think I already told a few of y'all, but me looking for adverse reactions, that is actually a thing. So there is, I know of one person that I read the article about, and I'll have to pull it out for you guys, but that does have an adverse reaction to radio waves. So they can't actually live here in society. Like, they live up in a mountain as far away from all of the radio waves that are going all around our phones and all that stuff, right? So there is such thing as reacting to that, all right? So I wasn't making that part up, okay? But for the most part, though, low energy really doesn't do anything, okay? So the next thing I want to talk about with this is your visible light spectrum, because I know a majority of us were like, Roy G. Biv, yeah, rainbow, woo, we got it. But, again, do we know what side things go on, right? So the easy way to kind of keep track of that and know what order to put your rainbow colors, Roy G. Biv, right? You look at what is on your spectrum, right? So infrared, that whole infra, and then it's red, right? That means before red. Match up that, all right? So this right here is telling me that I'm going to be starting with red. Ultraviolet means after violet, all right? So your red is on this side, and your violet will be on the opposite. So that is how you're going to put those into the correct order, right? And if you leave off the I, that's perfectly fine. I usually don't put indigo, but I was getting asked about it this morning. So BV is fine. All right, so about that, all right, let's talk about the color for a second, because you guys will hopefully be doing your flame lab thing Friday. We decided on doing that. So that being said, we got to know what we're looking at here. So if you've ever seen fire before, hey. Okay, if you've ever seen fire, what color do you see? Okay, so I heard orange is usually the prominent answer, and then I heard a lot more blues in this classroom, so that's cool. Yeah, that's what I was going for, blue and orange. So usually there's the orange flame and there's blue in the center. So which one is the hottest part of the flame, the blue or the orange? Blue. This is your evidence of that. Blue is up here, higher energy. Orange back here, lower energy. Hotter, colder. Okay? Make sense? So that's what you're going to be relating it to. Okay? So while we're waiting for the projector to turn back on, go ahead and take a look at number 10. because I don't think you need to see it. Okay, so for number 10, for letter A, it says, which has the longer wavelength? That means lower energy. Is it microwaves or infrared? Microwave. Okay. Which has the lower frequency? Which is lower energy. Is it X-rays or gamma? X-rays. Lower energy. Go away from gamma. All right. Which has the higher frequency, visible or ultraviolet? Good. UV. That's why we need to wear sunscreen, right? It's a little bit, right? Okay. Radio or infrared, more energy? Radio or infrared? What is it? Infrared. Yep. Infrared, just so you know, that's heat. That's heat. So if you've ever seen night vision goggles, it's kind of sensing the heat. All right. Which one has more energy, red or green? Green. Good. And then which one has higher frequency, which is higher energy? Orange or blue? Blue. And then finally, which one has the shorter wavelength, which means higher energy? X-ray. Okay, so we kind of said after visible, right? So we're going to higher energy side. You have to wear sunscreen for UV lights. You have to wear a lead vest when you go get an X-ray of your foot, right? They don't want the rest of your body to be exposed to that wave. Okay, and gamma, usually that's just not exposed to people usually, all right, unless you're doing that kind of science. So, do you guys have any questions for me on what we just talked about with that electromagnetic spectrum and those couple facts? Okay, so if not, let's go ahead and write in the different pieces of a wave. That way you have it on this paper. We'll worry about that 6 and 7 tomorrow. So up here, number 1 is showing you a wavelength. Number 1 is showing you a wavelength, okay? So they have from top to top is a wavelength. It can also be bottom to bottom, as well as middle to middle. Okay, notice I didn't just go to the next middle. That's a half. This is a full wavelength. All right. So those are all kind of showing you what a wavelength is, right? Which for the most part, you guys could tell this one was stretched out, so longer. This one is squished together, so shorter. All right. Number 2. Number 2 is showing us a trough. So the bottom part of the wave is known as a trough. Number 3 is showing us the height of a wave. It's always measured from that midpoint to the top part or the midpoint to the bottom part. That is known as amplitude. Okay. Number 4 is pointing to the top, which is known as a crest. And then number 5 should probably not be there because you can't really show frequencies. So I've been telling everybody, put an arrow to that middle line because that's your equilibrium line or your midpoint. You always measure from that midpoint up for amplitude. Okay? Amplitude. Okay, so you now have those answers. Yeah? We're all good? All right, cool.